Okay, guys, this is going to be part 2 of the solving systems of equations video, and we're going to look at how to use elimination. So elimination is a method that we use when both of our equations are in standard form. That means the x's and the y's are on the same side. And it's really easy. It's going to sound complicated for a second, but then once you see it, I think you're going to feel better about it. So elimination is used to cancel out or eliminate one variable so that you can solve for the others. So the way we do that is we start by stacking our equations so that the x's, the y's, and the number terms are lined up. So x's have to be over x's, y's have to be over y's, numbers have to be over numbers. Then you have to look for two like terms, so two x's or two y's, that are exactly the same or exact opposites. That means if you have a 5x to be exactly the same, you're going to be exactly 5x. Or to be exactly the opposite, you're going to be negative 5x. So you've got to find two that are exactly the same or exact opposites. If there aren't any that are already like that, you're going to have to multiply either one equation or both equations by a number to create that situation. So if one was a 5x and one was a 3x, you could multiply to turn them both into a 15 because 5 and 3 can both become 15. We'll look at some of that in just a minute. So once you get things that are exactly the same or exact opposites, then you're either going to add or subtract the equations so the like terms or the like term is eliminated or canceled. So here's what we do. If we're trying to cancel two things that are exactly the same, adding two things that are the same, like adding a 5x with a 5x would turn into a 10x. But subtracting a 5x and a 5x will become 0x. So when they're the same, we subtract. When they're opposites, we're going to add. And that's kind of helpful because you can know that same and subtract go together, and opposite with add. They kind of look the same, upside down, backwards-ish. Anyway, find some kind of way to remember that because that's important to you. Same, subtract, opposites, add. So we do that, and then we end up with a very small single-step equation that we're going to solve for the remaining variable in. Once you get that number, you use that answer. So use the answer to step 4 to substitute and find the value of the other variable. So let's look at how this works. So here's an example of a problem we could solve with substitution. X and Y are both on the same side. So this is set up to be ready to substitute already. My X's are on top of X's, my Y's are on top of Y's, numbers are on top of numbers. I got the equal sign there. So I've got to look and see if any of my variables are exactly the same or exactly the opposite. If they are, then I know I can eliminate that particular term. So I have a negative 4x and a positive 4x. Those are opposites from the same variable. So I can eliminate that. And because they're opposites, I'm going to eliminate them by adding. Negative 4 plus 4 will cancel and become 0x. That's going to be gone. I'm going to add everything else. I'm going to add negative 2 plus 8 to get 6y. I'm going to add negative 12 plus negative 24 to get negative 36. And I'm going to divide both sides by 6. So that little one-step equation that I have there, I just divide to finish it. And I get that y is equal to negative. I think I muted my microphone. Sorry. We get that y is equal to negative 6 when we divide both sides by 6. So that means in my solution, the y part is going to be negative 6. So I'm going to turn around from that, and I'm going to use that to find what the x should be. So I can use either one of those equations. It does not matter which one. And I can substitute negative 6 in for y and solve for x. So I'm going to use the bottom one because it's more positive than the top one, and I like positive numbers better. Again, it doesn't actually matter which one you use. So to solve this little equation, 8 times negative 6 is negative 48. Bring down my 4x. Bring down my negative 24. And I'm going to add 48, add 48. So 4x will equal 24. and x will equal 6. So my solution to this is 6, negative 6. Now, what I know is that you would very easily be able to type this in Desmos and get 6, negative 6 without having to do all of this work. I get that, and I think that is wonderful, and when you take your state test, that's absolutely what I want you to do, because that's going to guarantee you get a correct answer without wasting a lot of your time and without possibly making a mistake. However, when you take your ACT, Desmos is not a tool you can use. You can only use a TI-84 calculator for that. So you need to know these methods so that you're able to solve those questions on your ACT. Additionally, on your state test for me, there are going to be questions that ask you specific things about the elimination strategy. Like, if little Johnny were to solve this system of equations using elimination, would he add or subtract? You have to recognize that he needs to add here to eliminate the x's because they're opposites. So make sure that you're paying attention to these strategies. Even though you know you can get this answer without all of this stuff, you've got to understand how this works because there are going to be questions about that later on. So keep that in mind as we're working through the rest of these slides together. So let's do another one. Looking at this one, again, they're stacked up correctly. We have x's over x's and y's over y's and numbers over numbers. So I'm looking to see if either my x terms or my y terms are set up so that they can be eliminated. And so I need them to be exactly the same or exactly the opposite to be able to do that. And when I look at this, I see that my negative y and my positive y are exact opposites. So I can eliminate the y's because of that. So when they're opposites, we add to eliminate because negative plus a positive becomes nothing. And so I'm going to add everything else. 1x plus 2x will give me 3x. 11 plus 19 will give me 30. And I can divide both sides by 3. So that x is 10. So if I know that x is 10, I'm going to substitute that back into one of my two equations. I'm going to do the bottom one to solve for y. So 2 times 10 is 20. And we will subtract 20. And that'll allow my y to equal negative 1. So this whole process is not super, super difficult. You've just got to look for those things that can eliminate. Decide if you're adding or subtracting. Add when they're opposites. Subtract when they're the same. And then get your x, substitute back in to get your y. All right, let's look at another one. Again, check to make sure everything's aligned correctly. X's over x's, y's over y's. This one is good. So if I'm going to eliminate here, I've got to look for things that are the same or opposite. Here I've got a negative 6 and a negative 6x. So they're the same. That means I can eliminate those. Since they're the same, I have to eliminate using subtraction. So I'm going to subtract everything. So negative 6 minus negative 6 cancels. 6 minus 3 is 3y. 6 minus negative 12 is 18. We'll divide both sides by 3. So y is 6. Again, I'm combining these with subtraction because the like terms are the same this time. They're not opposites, they're the same. Same means we need to subtract. If you're not good with integers, like you look at 6 minus negative 12 and you think negative 6, use your calculator and check it. Don't make mistakes like that and mess your question up because of it. So once I get y, I'm going to plug that back in and solve for x. It does not matter which one I sub into. So I'm going to sub into the top one, negative 6x plus 6 times 6 to equal 6. That's a lot of 6's. All right, multiply. So negative 6x, 6 times 6 is 36. And then we can finish that by subtracting 36, which is negative 30, and divide both sides by negative 6. So x would equal 5. 30 divided by negative 6, or negative 30 divided by negative 6, positive 5.
Charlotte Irby, please go to your mom's room. Charlotte Irby, please go to your mom's room.
Sorry, y'all. This is after school, and that kind of stuff happens. All right, let's go. Now, looking at this one, our x's are aligned and our y's are aligned. But if you look at this, I don't have anything that matches. I have a 1x and a negative 4x, and I have a 3 and a 9. So right now, none of my like terms are the same, which means I'm going to have to look and see if there's a way I can multiply to make one turn into the other one. So if I look at this, I have a 1. Could I turn that into a 4 so that it cancels with negative 4? Yeah, I could by multiplying the whole equation by 4. Or I have a 3 that I could turn into a 9 to cancel the y's by multiplying the whole equation by 3. Either option is fine. You'll get the same answers regardless. So you can make the choice on what you want to multiply. I'm going to multiply by 3 and change the y's. But you could multiply by 4 and change the x's, and it would be perfectly fine to do that. I don't have to change my top equation because this is going to work so that I have something that matches. So I'm only going to have to change one. Sometimes you have to change both. So 3 times x is 3x. 3 times negative 3 is negative 9y. 3 times negative 6 is negative 18. So once I change that equation, I don't need the original one anymore. It's going to be gone, and I'm going to work to cancel with what I've got left. So 9 and negative 9s are opposites. When they're opposites, we add to eliminate. So 9 plus negative 9 will cancel, so I'm going to add everything else. Negative 4 plus 3 is negative 1x. 9 plus negative 18 is negative 9. And I'm going to divide both sides by negative 1, which means x is positive 9. Now, once I know what x is, I can turn around and solve for y by substituting that 9 in for x in one of the original equations. I'm going to sub it into that second one. So 9 minus 3y equals negative 6. So I just took the x out, put 9 in its spot. All right, so I'm going to subtract 9 to cancel it. Negative 15, negative 3y. Divide both sides by negative 3. And I get that y is 5. Okay, we're going to do a couple more together just to make sure that we're okay. And then I'm going to let you try a couple. This one is the same way as the last one. So we have x's and y's aligned, but we don't have anything that matches. I've got a 5 and a 3, and I've got a 4 and a 6. So I'm going to have to multiply to make them become things that can match. So I have options here. I can look at this 3. Now, there's nothing I can multiply 3 by easily and get a 5. You can multiply it by something to get 5, but not very easily. And there's nothing I can multiply 4 by to make it become a 6 very easily either. So instead of trying to multiply by some kind of weird obscure decimal, we're going to instead multiply both equations so that they both will match each other the way we need them to. So again, you can decide whether you're going to multiply your x's to cancel or your y's. So if I look at 3 and 5, I know that I could turn them both into 15s pretty easily. Or 4 and 6, I could turn them both into 12s pretty easily. So I can go with either option, and I'm going to get the same answer regardless. So I'm going to go with the x's this time. So if I'm going to multiply to make 5 become a 15, I'm going to have to multiply that whole equation by 3. If I want to multiply the bottom equation to make the 3x become a 15x, I'm going to have to multiply the bottom equation by 5. And that's going to allow them to become the same. Now, you won't always multiply by the same number, although you always can and it'll always work. But you won't always have to multiply 3 up here if there was a 3 on the bottom, or 5 up down here if there was a 5 up top. Just happened to work out that way for this one. So if I do that and I multiply everything here by 3, my new equation for that top is going to be 15x, 12y, and negative 42. And then the bottom equation will be 15x, 30y, and 30. And again, I'm getting that by multiplying everything in there by 5 or everything in the top one by 3. Once I do that, those original equations are not used anymore. And I eliminate using my new ones. So since I have a 15x and a 15x, they're the same, which means we eliminate using subtraction. 15 minus 15 will cancel. 12 minus 15, or 12 minus 30, I'm sorry, gives me negative 18y. Negative 42 minus 30 gives me negative 72. So I'm subtracting everything at this point. And then we divide to finish. So y is equal to 18 will go into 72 4 times. All right, and again, once we know one letter, we sub it into one of the equations to get the other. At this point, you have 4 different equations you could use, and you get the same answer for any one of them. So I could go into my new ones or one of my 2 original ones, and I can get the same answer for x that I would get no matter which one of those I use. So I always just pick the one that looks the simplest, which to me looks like that 3x plus 6y equals 6. And I'm going to sub into that. So 3x plus 6 times 4 equals 6. And I'm going to solve that. 6 times 4 is 24. And I'll subtract 24. And I'll get negative 6. So those that you have to multiply take a little more work. All right, we'll do a couple more together, or maybe just one more together, and then let you try a couple on your own. So looking at this one, I've got the same scenario here where I've got a 2 and a 3, they don't match. A 3 and a 4, they don't match. So I've got to multiply to get one to become the same as the other, or multiply both to get them both to match. So you could either decide to turn your 2 into can't turn into a 3, or your 3 can't turn into a 4. So you're going to have to turn them both into the same thing. We can turn our x's into 6's, because 2 and 3 will both make a 6. Or we can turn our 3 and 4 into 12, because 3 and 4 will both go into 12. Either one, whichever way you want to go with it. I'm going to do x's again, because that's a little simpler. Let me put a different color here. So if I want to make them both into 6's, 3 times 2 is 6, 2 times 3 is 6. So I'm going to distribute that 2 across that whole top equation to make a new equation. 6x, 2 times 3 is 6y, 2 times negative 12 is negative 24. And same thing on the bottom. 3 times 2 is 6x, 3 times 4 is 12y, 3 times 8 is 24. And I'm going to use my 2 new equations to do my elimination here. So this is gone, this is gone. So since my x's are now the same, when they're the same, we subtract. So 6 minus 6 becomes 0. 6 minus 12 becomes negative 6y. Negative 24 minus 24 becomes negative 48. Divide everything by negative 6, and y will equal 8. All right, from there, we take our y, sub it back into one of the equations. Could be one of the 2 original equations or one of the 2 new equations. Doesn't matter, you still get the same thing. I'm going to go with one of the originals because the numbers are smaller. And And so I've taken that bottom one, 2x plus 4y equals 8, took the y out, put the 8 in its spot, and I'm going to solve that. So 32 is 4 times 8. I can subtract the 32. So I have 2x, and I have negative 24. Divide both sides by 2, and I get that x is negative 12. All right. So take a minute, try these next two. Now, they don't require any multiplying because I've given you two that are already ready to do elimination with just to practice. So take a couple of minutes, pause the video, and try this one and the next one, and then come back and see if you were able to get the correct answer to both the x and the y for both of those problems. Okay, so take a look at this. For the first one, I got negative 1, negative 1. And if you're looking at how I did that, we'll need a little bit of time to take a look at that. I noticed that the 6x and the negative 6x were the same, so I added to cancel those because when they are, or they're opposites. I'm sorry, I said same, but I meant opposite. Because when they're opposites, we add. So I added 5 plus 4 and got 9, 1 plus negative 10 and got negative 9, divided by 9, got negative 1 for y. Then I used that, plugged it back into the second equation in place of y, which is what I did right here, and solved that equation to get a value of negative 1 for x. So my solution was negative 1, negative 1. If you missed that, pause the video and look closely at my work compared with yours. See if you can see where you made your mistake. On the second one, you should have gotten 6, negative 9. And again, that comes from over here. I noticed that my y values were exactly the same. So when they're the same, we subtract. And so I did 7 minus 8 to get negative 1, and I did 24 minus 30 to get negative 6, divided by negative 1 and got 6. And then I substituted that back in for the x in the original top equation and solved that equation to get the value for y, which came out to be negative 9. Again, if you missed that, you need to pause the video right here, go back and take a look at what I did compared with what you did and see if you can find your mistake there. But we know that we've got to subtract here because we've got to cancel something that's the same, and when things are the same, we subtract. All right, let's move on to the next couple of problems. So the rest of these slides, the last 4 slides here, are test prep problems. So they're questions that look like what you can expect to see when you take your state test. So I want you to take a minute, pause the video, and work through those 4. Use Desmos if Desmos would be helpful for you, or use one of the methods that we just looked at with elimination or substitution if you want to. A lot of it can be done in Desmos, so that's your best option as far as making sure that you're using a tool that's going to help you get the right answer every time. But do it in whatever way you're comfortable with, and then come back and see if you got the correct answer for what you picked. So pause the video, work those 4, and then come back. All right, so hopefully you've taken some time to work through these. This first one, you should have gotten an answer of D. And the easiest way to do this one was to graph your 4 answer choices in Desmos and see which ones looked exactly the same as what we have here. Now, if you did that and you picked a B, you chose one that had the same answer, but it wasn't the same exact system. And the reason we know that is because the line for B, the line that looks like this one, actually crossed at 3 instead of down here at 2. This one is the one that crosses at 2. And that's the one that you needed to pick. So it was a very close answer, but it was not the same thing. Sometimes these questions will ask you, which system is this? And you've got to make sure you're picking the one with the exact same lines. Sometimes they'll ask you which system has the same solution as another one. And then it's okay to pick one that's not exactly the same as long as that point of intersection is in the same spot. But this one wanted to know which system is represented by this graph. And we had to pick the one that was exactly the right one with exactly the same lines. So D was the one that did that. In this second one, this is maybe the hardest one of the group because you actually had to have a good understanding of how to use elimination for this. And so they talk about multiplying the equation so that you can create equivalent expressions that you could use elimination to solve. And so when you look at that, we have a 4 and a 5, and we have a 4 and a 5. So we know there's no way to multiply 4 by anything to make it into a 5. directly. So we had to multiply both equations, which means you should have, from the beginning, eliminated A and B. Because they have you multiplying both equations by the same number, and that doesn't work here. So then we had to look at our other options that had you multiplying one by one number and one by a different number and see which one of those is correct. Now, one says to multiply by -4 and one by -5, and that could potentially work. But the problem is, if you multiply the top equation by -4, you get -20x, which they got, but then -4 times -4y would make positive 16y. They got a -16y, so that's wrong, which is why D works. They multiplied by -4 and ended up with that positive 16. And they multiplied by +5 and ended up with all positive values here. So D was a good choice. If you look at this question, you're like, I don't have the slightest idea what any of this is, and I don't know what in the world I'm supposed to multiply by, and I'm stumped. Your best option in that situation is to graph the original one in Desmos. So graph this. And then go graph your options here. So like this equation and this equation, and see if they're the same. If they're not, you know that's not the right answer. And then you keep going and doing that with everything else until you find the ones that do that. They overlap in exactly the same place. Because multiplying an equation by a certain number creates an equivalent equation. So they're going to still overlap in the same spot. So if you don't have any idea how else to look at these, that's going to be the option you want to go with. Now, this one asks you where you end up with no solution. And remember, no solution means they never cross. Lines that never cross are parallel. If you see this word coincide, that means the same. So that would be infinite solutions, would be coinciding lines. That means they're the same line. But parallel is no solution. So we needed answer choice B there. And then the last one, you could put that in Desmos, find the point where they crossed, and they crossed at 3, 0. So that was your easiest bet for that. You might have solved that with elimination, but it wasn't necessary to do that. You'll have the tool of Desmos to use. I would absolutely use a tool like Desmos to solve a question like that. All right, that is the end of the second part of these notes. Y'all have a beautiful day.